All right. Hey, welcome. Great to see so many people in the last slot of the day of this conference. I'm really proud of you, and thank you so much for coming to my talk. You might think like, this guy from Atlassian coming here to Porto and talking about developer joy. Why does he do this? I mean, we as software developers have already the best job in the world, right? We are creating things for customer that really uses it. We are just like creative people. We just like enjoy what we are doing, right? It's just like fun to work as software developers. It's so good, such a great job. So why in the hell is this guy coming all the way to Porto and talk about developer joy? And I will tell you why. Because software development has actually changed in the last 10 years. If we look at it, so back in the days, it was just like writing code, right? We were writing code, we were getting requirements, great. But the last 10 years have put some more stuff on our shoulders, right? So if we look at it, the cloud came, of course, yeah. Okay, technology come and go and changes, that's great. So the cloud actually has changed the way we work, right? We needed to learn new things that are just working in the cloud and not working on demand, right? Containerization, running things in little containers, spin containers up, observe these containers, what are they doing, right? This is all new to us. We had to learn new paradigms. Back in the days, I was just like spinning up my first container, had a log file, wanted to see the log file after the container was down. But of course, yeah, the log file is also down if the container is down, so I couldn't see it anymore. So these are the things that we all had to learn. Microservices. What do we do if the service is not there on the other side? When we're building a monolith, we know we can call this code, but can we call the service? What happens if the network between services are down? We have to define a clear API. What is if the API is changing? What are all the dependencies between microservices that we have to take care about? All of this came in the last 10 years. And don't let me start it on security and governance, right? It has to do with things are now publicly in the cloud, and we have to secure those things. And of course, yeah, thank you very much, Werner Vogel, for you build it, you run it. We're not just like writing software. We're not observing just like what's happening in the software. Now we are also responsible for running the software in production, and we get a call. We are on call now. If the service is down, we have to do something, right? So all of these things has been put on the shoulders of developers in the last 10 years, and all of this has counted to more developer cognitive load. We have more stuff that we have to take care about. Don't get me wrong, all this DevOps stuff is great, right? We just like, it's obvious that we needed to move into that direction, but it means also more cognitive load, right? And now I'm talking to a lot of CTOs these days, and they say, Sven, just like, how can we get back to productivity, right? How can we get our software developers more productive? How can we do that? Guess what? That's the wrong question to ask, right? It's the wrong question to ask, right? But I come to that in a bit. I just like want to go a little bit, where does this obsession come from? For productivity, everyone is talking about how can we make things more productive, and we have to travel back in time for that. Are you with me? Are you okay with traveling back in time with me? Oh, a little bit resistant, I can see that. Yeah, I promise you, I will bring you back to the year 2023 afterwards. So no worries about that. So I count to 3, and then we travel back 125 years in time. 1, 2, 3, boom. So here we are, right? The year is 1898, and we are in the Bethlehem Steel Factory. So the Bethlehem Steel Factory, at that time, they actually had some productivity issues. They were just like thinking, what can we do? So the owner of the factory said, okay, what can we do actually? And at that time, there was no McKinsey or Boston Consulting Group that you can call up and they come in with a bunch of consultants fixing your productivity issues and go away. That didn't exist at that time. But they found one person, and his name was Frederick Winslow Taylor. Has someone heard of Frederick Winslow Taylor before? A few of you? Great, yeah. So he's famous for his Taylorism. But what he did, actually, the first thing that he came in was putting out a stopwatch. So he put out his stopwatch and just like was measuring what the workers were doing. And there were some obvious things like how the work was arranged, so he changed that, improved productivity. Ways were shorter between two stations, so fixed that, improved productivity, great. But he also noticed some other stuff. He noticed like when people were using were shuffling coal, he saw like things were falling left and right from the shuffle. So obviously he just like gave them custom-made shuffles that were made for shuffling coal. So also that increased the productivity. And then he also noticed that the workers could carry more in the morning and less in the evening, obviously, right? Because they were just like exhausted in the evening. So what could he do, right? So what he did was he gave the workers more breaks, actually. So give them breaks in between. So throughout the day, the workers could carry more. So all in all, and he did a lot of things, right? All in all, he increased the productivity of the workers in the factory by 400%. Boom, right? Great. So let's do that with software development. Now, wait. There is one thing, everything comes with a flip side, and the flip side is that Frederick Winslow Taylor introduced new roles in the factory, right? So the workers that were very engaged and working were now just like doing repetitive tasks. They were just like, they get told by the managers, so he also introduced the managers, they're responsible for the productivity. Also, now they get told from the managers what to do. Sounds familiar? Well, okay, it's 125 years ago, right? And I think just like, people tend to fall back to things that has been working in the past. Just like if you get pressure as a manager and say just like, okay, we need to improve productivity, you tend to look back and say, okay, we know just like if we optimize these small things and measure things and optimize the hell out of it, we will improve, right? We will improve. So back to the year 2023, I promise you I'll bring you back. We now think about just like how can we make our developers more productive and how can we measure first the productivity of our developers. And in the first job that I got in, it's a long time ago, my manager asked me, Sven, how many lines of code did we add in the last quarter, right? Just like I want to just like say to the management, just like how great we did. We all know that's just like a bad measure for productivity, right? Counting lines of code. I can add a lot of lines of code, but not being productive at all. So we try to find other things, how to measure productivity. And one thing was just like, okay, we count the number of issues that we move into done. Very easy, very good. It's okay, but also there are small issues and larger issues that we have to work on. So also not maybe a good measure of measuring the productivity of the software developers. But the next thing is just like, okay, just like weight those issues, right? So we just like counting story points, like how many story points that we count down, or even better and even easier, right, is t-shirt sizes, right? How many t-shirt sizes? It was S story on M story on L story. Great, but you know what? It's an estimation. I'm doing this before I actually do the job, right? So this is also not a good measurement of my productivity, right? I could estimate, yeah, it's a small one, but then I figure out, okay, it takes longer, it's more complicated, and it stays a small issue, right? You don't do that. But also, just like now we have great measurements, and you've heard about it, the Durham metrics, right? The cycle time, right? Or the deployment frequency. But also here, I can easily game that metrics. If someone says to me just like, yeah, we need more cycle time, right, or a shorter cycle time, yeah, I make my issues smaller. If you need more deployment frequency, same thing, just like I can deploy smaller things frequently, right? And then Frederick Winslow Taylorism comes again, just like, okay, now we have the perfect measure. Let's say we have the perfect measure. Now we're putting pressure on the software developers and say just like, yeah, great, you're doing great, but we need to be more productive. So increase that or decrease whatever it is, right? Thank you very much, Frederick Winslow Taylor. Still, 125 years ago, he's still influencing our management and the way we work as software developers, right? But there's hope. There's hope. Don't worry. And we call it actually, and you might have heard of it, just like improving the developer experience, right? Let's improve the developer experience. That's a better term for that. And to be honest, I like that term. I think it's very good. It's just like describes it way better. I want to have a great experience while developing, being more productive by that. Great. But already now, we can see consultant companies coming in and coming up with new frameworks and selling those frameworks. And all of a sudden, we have a certified developer experience manager or master or whatever, right? Or McKinsey that came up with some measurements of how we measure productivity for developers, and very stiff with story points and so on. They got a lot of bash by that. So we think at Atlassian, we just like want to take it one more step further, right? And we say we need to get back to why we enjoy what we're doing, right? Why did we become developers? And why do we enjoy our job? How do we make our job now more enjoyable? Bring that back into software development. And guess what, right? If you enjoy what you're doing, and we believe in that, you're also productive, right? You're also getting productive. So what do we mean by that? So let's take it apart, right? Developer joy, right? So if you work on great quality code, right? Code that you just like when you open your IDE in the morning and say, yeah, great, I will love that code. It's so good, so great quality. It's so good. I love to work with that code. Or yeah, I have this idea on Monday and deploy it on Tuesday. Great developer flow, or I'd grab this and it's just like runs through no dependencies. I can just like do it all on my own. Great. So speed is something that is also important for us. Or also when I can deliver value, when I get feedback from my customers and say, Sven, we love what you built here. It's really helping us. It's really helping us in our daily job. You know what? I super enjoy what I'm doing, right? I'm enjoying my job. It's great. At the same time, I'm also productive, right? Because I'm delivering value to my customers fast, right? With great quality. Wow, cool. So I brought some stories with me from teams within Atlassian. What they just like suffered with something and fixed the thing. So I have some stories here how great teams get stuff done. And we want to talk about quality first, right? And there's the term technical debt, right? And we just like did a survey amongst developers worldwide and just like asked how much time do you spend on technical debt. And 42% of the dev time is used for, that's what we got, used for technical debt, right? Fighting technical debt. Wow, that's a lot, right? A lot of time that we spend with technical debt. And then we look at it, and then also 10% of the dev teams actively manage their technical debt, right? What is with the rest 90%, right? That's just like a downspin, right? We get more technical debt in there. But how does it actually happen, right? How does code get unmaintainable or just like harder to maintain? How do we get this technical debt in? Because if you start writing something, it all turns out nicely. Let's assume this is just like a nice class that I've written. Great, I'm proud of it. It's pretty simple, doing what it should be, right? Great, okay, move on. I'm going on vacation, right? And then 2 weeks after, I just like want to look at my great class again because I needed to change a little bit in there. And I open the IDE and then I look at my awesome class and what have my coworkers been doing with it, right? They added a lot of stuff, right? And sometimes things end up in a mess. So also, my coworkers are great, right? So they didn't want to just like say, oh, this Sven has written this great class and now we mess it up. That's not their intent. But maybe there was something that I had to fix something, put it in, right? And just like write it down. They wanted to fix it on a Monday morning, right? Deploy it on a Friday, fix it on a Monday morning, and then Monday morning, there were some other issues and they forgot about it. We all know that things happen, right? So the Bitbucket team had some problem with that, actually. The question that they say is like, what is good code, right? That's the first question, like, how does good code look like? And do we agree as a team on that, right? As I said, the Bitbucket team, Python developers, they had that. So they wrote down their coding guidelines. And I hope maybe you have coding guidelines. Maybe they are in Words. Maybe they are in some automatic tooling. They're checking that, right? So they wrote down their Python coding guidelines, and it's important for them. So they agree on something and say, this is what good looks like, right? This is what we value as good code, right? So not only that you now have just like a quality level that you want to just like say, okay, this is good quality code, but also your code gets more readable because everyone agrees a little bit on coding styles. So, and I know a lot of tools out there that can check the coding styles automatically, but not all of it, like single responsibility principle. I haven't seen a good tool that really gets that right? So how do you check those things, right? I know AI is coming and probably they can check that. But right now I haven't seen anything. So what are you doing, right, to check this if the single responsibility principle, for example, has been violated or not, right? Like in my example. Well, what you do is obviously you're doing code reviews, right? So you're all doing code reviews, right? Yeah. Okay. Great. Good. Just to get clear here, right? Great. So. But there's a big problem with code reviews because I think humans are involved. I think I don't know if that's a problem, but that's just like an issue sometimes with code reviews. So let's assume I've added this lines of code here, and then I put my pull request out there, add the reviewers. A reviewer comes in and says, "What the fuck, Sven?" And I say, "Oh, okay. Well, I just like, what do you mean? Like, tell me more, right?" And then this code is ugly. I said, "Oh, come on, right? I'm already done with code reviews, right? I put myself out there, my work out there to all my coworkers, and I get this feedback, right? I don't want to do code reviews anymore. But hey, I'm a polite person, right? And I just say, okay, what do you mean by ugly? I don't understand, right? And then it would have been nicer if you would use a for loop, right? So, okay, great, nicer. I don't get it. What do you mean by nicer? Anyway, so if you just like do kind of these code review comments on the pull request, right? My advice is don't be a jerk, right? Don't be just like the smart person that understands everything. Don't be a jerk, right? Be polite, right? So who here actually has been bullied by a jerk recently, let's say in the last months? Okay, you don't have to raise your hands, please don't, because I know your coworkers are in the room, so all good, right? All good. Okay, I see you. All right, yeah, so there's a lot happening, like a lot of bullying, right? But these reviewers are actually the reason why people hate code reviews. People just like, I put my code out there. And if you look at it, the Jira team actually, let's say they didn't have that extreme problem, but they had some tension in the team with code reviews. So they needed to fix that. So they just like took it from a step back and just like said, okay, let's review that, right? The reviewer is always in this protected bubble, right? It is the author that open themselves up, right? And just like get your feedback about their work, right? So they just like said, okay, we need to set up some rules to be polite with code reviews, to be respectful with code reviews. So they said just like, okay, first rule here, assume competence, right? We hire people for a reason, and they go to job through interviews, and a lot of people are looking at them. We assume that we have hired competent people that can do their job. That's the first thing, right? Assume competence. The second thing is be constructive in your feedback. Like this code is ugly, that's probably not very constructive, right? Just like be constructive if you write feedback, and also explain your reasoning. A for loop would be nicer, right, than a while loop. Just like explain to me why. I also want to learn from it, right? So they have set up some more rules and written that down. So they have their code review etiquette set up. So everyone just like has to follow that. And if someone violates that etiquette, then they got called out and say, hey, look at the etiquette where we have set that up. We agreed as a team that this is the right thing to do. This is how we want to work together. Just like reminding people that this is a value that we have created as a team, right? So, what does that mean? Better reviews means actually no bullying or less bullying, hopefully, and at the end also more developer joy. Like I enjoy more working with my coworkers if everyone is nice to me and I can actually actively learn something from my coworkers. Great. Another thing, like another team that has been had some problems was actually the Confluence team. So the Confluence team actually they were, like hopefully every one of you, writing automated tests. So they were writing tests, and sometimes actually what's happening if you just like run your test, you add some new code and you run your test, and the test turns red, right? But what has happened, right? I need to just like take a look at that. So what you do is actually, shit, the test is red. I just like look at the code. What did I change? You investigate, you look at it for 20 minutes, half an hour, and you can't find why the test fails. You look at the log files, it doesn't make sense. You don't know, right? So what do? Well, what most people do is they just like, okay, let's rerun the test, right? Let's do it again, and then boom, test is green. Great, we're all like, fine, let's move on. Wait, right? You have heard of flaky tests, so we just like discovered a flaky test here. All right, it's time for a commercial. I'll be back after the break, right? See you after the break.
Is seeing red build after red build getting old? Is rerunning your failed jobs getting you down? Is waiting on those failed jobs to finish making you crazy? Deterministic Reliability is here to help. With our handy-dandy flaky test monitoring system, we will, eventually, automatically bypass those flaky tests. For 4 easy payments of free, you too can save time, ship quality code faster, be more productive, feel so much better when you go to work every day. You will be happier, your team will be happier, you'll stop dying inside, you'll stop banging your head against your desk, you'll stop replacing computers that are in a rage against the wall. Sorry. It's just a little close to home. Call 1-800-Atlassian today to get your free flake monitoring system.
All right, don't call Atlassian. We haven't done a flake monitoring system. It's not out there. We've built it ourselves. So the team actually built the flaky monitoring system themselves. So it works just like super easy. If you create a pull request, right, the build and test kicks in automatically. The test fails and said, oh wow, the flaky test detector comes and says just like, oh, let me rerun the tests 3-4 times. See what's happening, test passes, flaky test detected. Great. The next thing what's happened is just like the test gets automatically noted as skipping the test because it's flaky. And then also we add a comment to the pull request that someone has to look at it and check it and repair it, right? Make it less flaky. Or maybe the code is flaky, even worse. And then also you get a message in your chat tool where you can just like see, okay, someone needs to look at that. All right, so it means just like we're trying to have better tooling, right? Better tooling, less debug frustration, right? Just like spending time debugging things and just like don't find the cause of it, and at the end also more developer joy. So. Great, good quality. Now we're just like getting more into the developer speed, right? And if I talk about speed, I talk a lot about flow. And me as a developer, I love flow, right? And when I'm in the zone and I can code, right? That's just like the best time ever, right? I can solve problems easily, and it's just like I'm in the zone. But unfortunately, software development is not writing code, right? It's much more than that. It's not the coding phase. We also have the build and test phase and the deploy phase. So even though if I just like cancel all my meetings and all the things, right? There's some time that it's been wasted here. So build and test can take hours. You can cut them down to minutes. You can do test parallelization and all those things, just like to cut that time down. And then also deploy fast, just like deploy small microservices. That also means just like you can cut that time down. But this is significantly smaller than the thing that happens in between, and that's the review phase, which can actually take days to review your code, right? The code reviews. And again, the Confluence team had that problem, and they were just like measuring it, like how much time does it on average take from opening a pull request to merge it back to the main branch, right? How much time do we need for that? And the answer was 3 days. Right, an average of 3 days, right? You might think like, sounds like familiar, or just like this is just like way too much. We think it's way too much. We just like want to cut down that time, right? And that means also 3 days of you as an author working on something else, right? And then just like reading all through the comments and coming back and remember, what did I do when I was writing this thing to get back to that thing? So, as I said, one team of the Confluence team just like wanted to do something about it and wanted to change it. So it was actually not the team, but their team lead, Punit Arora. So Punit Arora was a team lead of a Confluence team. And what Punit did was, Punit was just like coming in early in the morning or just like starting his morning very early and just like looked at the open pull request for the team. And then also just like pinged everyone that was a reviewer and says, hey, you might have missed the notification yesterday, but you're on an open pull request, and for your coworkers' sake, right, that they can move on quickly, just like please start your day by reviewing the pull request. So just like do something and then get into the zone, right? We don't want to interrupt you, but you know, you might have missed it. It's fine, right? But please review that pull request. And it really worked very, very well to that point that people were saying just like, Punit, we know that's not your job, right? And in the hackathon, they replaced actually Punit with a bot, right? Called the Punit bot. And now the Punit bot comes in every morning and just like sends you an email and says, hey, you might have missed that pull request that you're on, right? And fix that. So success here, the Confluence team actually, from 3 days, they went down to 1.2 days. They learned some stuff along the way. If the pull request is too large, no one is, just like it takes longer to review, so we have to make that shorter. So all these learnings came in, and they ended up at the 1.2 days. Still room for improvement, but that's where they are, right? All right, so faster reviews, right, means less wait time for developers and more developer joy, or working on something else and coming back. As I said, I'm obsessed with flow. And also how work flows through the team. How do we do that? And I want to just like make a comparison to traffic. So I have downloaded this traffic simulations of just like how traffic junctions work. And it simulated cars that want to go through the junction. And the first one is just like totally chaotic, right? So it's just like cars trying to find their way. They stop, they just like slow down and find their way. And in this simulation, the traffic flow is 191 vehicles per minute that can pass that junction. Okay. We don't want to work that way, right? We don't want to work totally in chaos and we have to wait for someone and we can't predict how long that time takes. So let's add some processes here, right? Let's add some heavy processes like traffic lights. So one team needs to stop, the other team can go full speed, right? Or the other cars can go full speed. Also, this is a simulation of a junction with traffic lights. And obviously, we could actually, in this simulation, increase the traffic flow to 235 cars. So processes might help to just like direct work in the right direction, right? Might help. But we're agile. We just like want to move on. We also don't want to stop, right? We want to move on. We're just like agile. We work in small iterations. So it's a little bit similar to this roundabout idea, right? If there's a slot in the sprint, we slot the work in. If there's actually also a fast lane where we can slot in work faster. And yeah, we also increased the traffic flow here to 360 cars per minute. Great. We have it, right? Agile is the solution here, right? It's great. It's okay. But there's one more thing, and that is the stack interchange. Yeah. You can see no car is slowing down, right? Every car is just like going at their speed. They get maybe a little bit slower, but then they automatically move and merge into the next lane. And in this simulation, we get 1,099 cars per minute through this stack interchange. Great. So how do we build that for work, right? How do we build that for work? And the answer is clear. If you don't want to slow down, you need to build autonomous teams, right? Teams that can work and not depend on other teams. Well, this is probably a fairy tale that we don't have to depend on other teams, but we need to strive for autonomy. We need to strive for more autonomy, which doesn't mean we just like work in a vacuum, right? We need to align our efforts to accomplish something bigger and work together as teams of teams. But what do we need for an autonomous team? We need everyone on the team, right? We need designer on the team. We need developer on the team. We need QA on the team. We need operations on the team. So we can't just like dive in. If you want to have need designer work, they are on the team. You can just like tap into that. We have all the same goals. Great. But also that doesn't really work. The Trello team had that problem when they were just like trying to work more with QA, and QA was actually a bottleneck, right? We can't have a QA engineer on every team because the ratio that we have is 1 to 30. So 1 QA engineer to 30 developers. We can't actually hire. And also there's probably not a full-time job on the team for a full-time QA engineer all the time. So what they were doing, just like they were looking at how they actually worked. So the developers were doing the automated tests, and QA was checking the exploratory tests. So going through test plans, writing test plans, going through that, making sure that nothing breaks. So in an autonomous team, right, the developers are taking over the job of the QA, right? So we call that quality assistance. So the QA people are still there, but they assist just the developers. And the developers are actually responsible, all of a sudden, also for the quality of the code. They can't just say, okay, QA will check it at the end, that everything is fine. They are responsible end to end. So how do we do that? So what we did is this one thing, like we're doing QA kickoffs. This is what teams at Atlassian do. So how that works is you take your user story, you read through a user story, you take a QA engineer, you partner with a QA engineer, and then you write the test plan before you implement anything, right? Before you write any code, you just like write the test plan, and this is how we would test it. That way, the developer learns how to become better testers, and also they can implement the feature and then don't wait for the QA engineer. They can just like run through the test plan because the test plan has been written before, and they just like run through the test plan and deploy the feature, right? There's one more step in there. They're called demos, and I come to that later. But in general, it is like this. It goes like implementation, testing, demo, and then they can deploy it, right? So they don't depend on the QA engineers anymore to just like deploy the feature, to put it into production. Another thing that we do when we're not certain, right, we're calling in for blitz test. So blitz test, the whole team takes a feature and tests the hell out of it. There will be a QA engineer also involved that is just like taking all the notes and writing down what needs to be fixed in the first version, what can wait maybe a little bit. But this is just like the whole team comes together and tests the critical feature to make sure that this feature is good for deployment. And then the QA engineer, of course, we free up their time. So they actually help the developers with test environments, test databases, test data, all those things. This is what the QA engineers are doing, what the developers don't need to do on top of it, because that's what they do. So they take away some burden from the developers, where the developers also take more on responsibility for quality, for the quality they produce. So less developer cognitive load because QA takes over something from the developers, and that means also more developer joy. All right, so the last thing was the developer value that I want to be proud of what I'm building, right? But in large organizations like ours, we have actually people for just like talking to customers, which we call the product managers. These are the ones. And then on the other planet, there are the developers, right? And we have this small little pipeline where they pipe work through to us, and we just like develop it, and then the product people can take care of it, right? So just like a small story here that I really experienced back in the days when the product people was writing a user story for me and saying, hey, as a user, I want to export the data so I can have it in an Excel file. Great. There's a little bit more to it, but I was just like saying, okay, great. Yeah, I can just like do it, give it back to the product manager. The product manager says, oh, we don't need all the data, right? We don't need all the data from that person database. We just like need some of this. So, okay. New user story. As a user, I want to export the important data so I can have it in an Excel file. Done. And then the person said, there's a difference between Excel and CSV. I didn't know, sorry, right? I need a CSV file. So, okay, good. New user story. No problem, I can do that. As a user, I want to export the important data so I can have it in CSV file. Great. Now, here you go. Oh, great, that works perfectly. So I can now import that into our CRM system. I said, what? You want to just like export and import it? Our CRM system has APIs, so I can just like shuffle over the data. So I was super frustrated with the last user story I had to implement. As a user, I want to export the data so I can import it into a CRM system. Great, thank you very much, product manager. We should have talked before, right? And that happens actually, maybe not in that extreme, but that happens actually. So the product people, I don't want to blame the product people, they do a great job of doing research, measurements, interview the customers, do little experiments with the customers, maybe with paper prototypes and all those things, right? Great work. But what then happens is actually they squeeze it into a user story, and we should guess what we should build, right? Or we just like think we know what we built because it's in the user story, but the user story can't carry all the stuff that they came up with, right? So the Jira team, they were really suffering from that, right? Not good relationship to the product managers. So how do we actually get from here to just like let everyone work together on the same thing at the same time? Doesn't mean that we now all become product managers and we have to just like be involved in customer interviews and that. We were looking a little bit on the development phases that we have. And the developers are probably more involved in the make phase, right? So making the software, creating things, creating value. And the product people are more involved in the what we call the wonder phase, where what is the problem that we need to solve? How do we want to solve it, right? And then also we have an explore phase where we just like explore more solutions, right? Not the first solution that we think will help the customer is the best solution. We come up with just like, is that really something that solved the problem? So there's also a phase here. And of course, at the end, we need to just like measure the impact. Right? What did we create, right? Is that really, so does that really solve the problem that we just like came up with in the first place? Even though it sounds very waterfall-y here, I guarantee you there's a lot of back and forth between those phases. So, and I don't say that developers now, we need to just like cover all those phases in the same amount of time, right? We are more heavily involved in the create phase, of course. But we need also to be involved in the wonder phase and understand the problem that we need to solve with our software, right? Where the product people are probably more involved in the wonder phase, but hey, we also need them in the make phase. They need to give us feedback, right, in the make phase. So how do we do that? So as of last year, we came up with just like this concept, and we just like say, okay, we put in milestones. So really, every project has to go through those milestones to just like not miss the understanding of the other team. So we do project kickoff. So once the product managers have identified the problems and give us the measurements and all those things, we do project kickoff where we invite designers, IT, everyone, right? Everyone that is involved in the project just get into the project kickoff. We're building prototypes together, and sometimes Figma prototypes look nice, but if we put that into software, it doesn't work, right? because just like of some technology that doesn't work out. So we also need to make it. We also need to build our prototypes to make it to see if it's technically feasible. What the product people came up with, and then during the make phase, we're doing regular demos where we invite everyone, and then also for the impact phase, we're just like going in a retro and just like looking at the numbers and just like see how can we make the thing better to get a better understanding what we build for the customer and also for the developers to see just like what is actually the problem that the customer has with the current solution to fix that also for futures. I don't want to talk about all these things, but I think like as software developers as we are, right, the demos are the ones, and this is just like a nice picture, but this doesn't look, the demo doesn't look like this anymore. We just like all distributed and we work remotely, so it's more a Zoom call. But also the thing is we record the Zoom calls and I can see all the demos from all new features that teams are building, and I can just like go into the repository and see all those videos, right? So I can attend those demos. So a demo, first thing, it's super important that it's open. Everyone can join, and sometimes even a founder jumps into a demo and looks at it and just like want to know how is the state of development, which can be scary, but it's open, so QA people, I told you, just like, they want to just like maybe look at what the developers have built, has done, right? And then say, oh, have you tested this too? So, but also important for product managers to be there and see how the developers have built this thing. It's outcome oriented. So we don't want to talk about implementation details in those demos. We talk about the outcome, the value that we create for the customers. And then we discuss things, we challenge the solution, and sometimes product managers come up with, yeah, that's what we have written down, but now that we see that, let me just like bring that back to the customer and see if that is really what they wanted. It looks now a little bit like, not what we thought it would be. And then also we just like sitting together and want to celebrate together, right? We want to celebrate our wins. If we just like have deployed already a small user base and see just like, okay, adoption rate is great, all right? So we want to sit together and we want to celebrate together because we all build this together, right? We all build this product together. It's not just like the developers have this part, the product people have this part. We all build something together. And that's also what the demo sessions are great for. So all of these demo sessions, it means actually less rework frustration because we don't deploy anything and then find out, that wasn't what the product managers were thinking or what the customer wanted to have. Less rework frustration and more developer joy. The question is now they saw all these great things, right? But what would Frederick Winslow Taylor say, right? Coming in with a stopwatch, right? Is that really improving productivity, right? Is that really helping to be more productive, right? Not Frederick Winslow Taylor said that, but it was Peter Drucker that said like, if you can't measure it, you can't improve it, right? So we need some kind of measurement to see just like, what is it, right? And if you just like don't measure anything or something, a good start is of course the DORA metrics, right? Start with the DORA metrics like change failure rate, deployment frequency, time to restore, and lead time for changes. The four most important DORA metrics. Start with that, but it doesn't make sense for all the teams, right? Think of it like deployment frequency for a mobile team probably doesn't make sense to deploy it every 2 hours to the App Store. Is not a good idea, right? So look at what is really important for your team, right? The software that you build. And also maybe look at where do you really struggle, right? And take those measurements and try to see just like improve those. Because every team is different, every project is different. So we use actually our own tool, Compass, just went GA this week for doing this. It's a developer experience platform. And you can just like see we have the DevOps health there. It's made of different things. And also we have baselines. So we see just like if something drops below a baseline, right, it turns yellow or even red. Great. So it's in that tool, right? So you need to just like get it out somehow, and that's maybe also the problem. You know, back in the days, we had all these wallboards or TVs in the office where we could see just like the build states of certain or test state of certain tests that we were running, right? And if one test is red, great. But if all tests are red, right, you just like that's really a problem because you keep to ignoring it, right? Software is running, tests are red. I don't care anymore, right? So what we do is actually with this metrics that we have, we just like look at it and talk about it. And we call that checkops. So checkops is important because sometimes your deployment frequency goes down and the number shows red, but obviously you're working on some complicated part of the code. And of course, yeah, you know, as a team, deployment frequency goes down. That's just like, okay, right? Or half of the team is on vacation, yeah? All right, we just like, we know that, it's fine. So the metrics, treat the metrics as just like signals, right? And just like talk about it and see what you need to really improve from the metrics that you get. Also, we have built that directly into Compass, so we can do just like the check ops directly into Compass, and then also write down what actions you want to take from that week. And we, as I said last time, we're measuring, of course, a lot. We're measuring, of course, also the capacity and how much issues and how much time we spend on different activities. And we wanted to keep it simple. We wanted to just like see, okay, how much time do we spend on activities here? And we just like have these two categories where we put in issues or tasks, right? One category is just like how much time do we spend on, or how much effort we do spend on changing the business, which means new features and all those things, right? But then also, how much time do we spend on keeping the lights on, right? And then the lights went off here. I don't know. Funny. So how much time do you keeping the lights on? So how much time do you spend on this? And we found a good ratio for some teams. For most of the teams, it's a 60-40 ratio. So minimum 60% of changing the business and 40% of keeping the lights on. But this is not true anymore because we also are keen on improving our developer productivity. So we're also measuring how much time do we actually spend as a team on improving our developer productivity. And we just like have a goal of 10% of the time minimum spent on developer productivity issues. So the team gets minimum 10% of the time to spend on that. And as I said, we're measuring that. It's a pretty simple system. We just like take our Jira issues and put labels on it, and so we can just like categorize it that way. Pretty thing, and you can just like see here, okay, 1 month we were a little bit over the 10%, and then under the 10% of developer productivity, the purple bar here. So all great, right? Measurements are showing you great stuff and great signals. Well, until the GitHub Good Day project. I don't know if you heard about that. So they actually did an experiment at GitHub, and they were just like asking developers, how did you feel? How productive did you feel today? Was it a good day, right? How was your day, right? And then they tried, and then developers were just like saying, yeah, great day, I did a lot of stuff, or not so productive today, I don't know, sat in a lot of meetings, or nothing really worked out. And then they tried to correlate that with some activities and some metrics that they saw. And guess what? They couldn't find a correlation between those two, right? It's just like how people feel. So poor Octocat here. And I would say, like, don't treat software development like this, just like, oh, we have 12 days for the idea phase and 1 day for the coding and 3 days, and we need to optimize that. Don't get in the Frederick Winslow Taylor mode again with your measurements, like to try to optimize that, because software development is not a production line, right? We don't produce the same amount of code over and over again, right? We don't, like cars, like the same car over and over again. We know how to do that. Some things are more complicated, some things are more easier, right? It is not a production line, and we need to take it case by case. So another quote here: measure what is important, but don't make important what you can measure. Just like take these things as signals, right? And as you just like saw on the GitHub example, right? Why don't you ask your developers? how do you feel, right? How are you satisfied with your development? Which is a little bit like very loosey. So what we actually did is we were running regular developer surveys, and we are asking the same questions, and we have some certain areas where we say just like, are you satisfied with that? And these are the areas. So first thing is just like, are you satisfied with your speed to ship quality code? Are you satisfied with that? Second thing is, are you satisfied with waiting time? Is that okay, or is that too much waiting time? How about the execution independence, because we think it's super important. The access to tools, processes, and practices, because we also think like with great tools, great practices and processes, people can just like be more productive. Effort of managing external standards like security and governance that are put upon developers. How about the time that you spend managing the code, the pipeline, and the infrastructure, so more like keeping the lights on. What about ramp-up time? That was just like, it's a very important thing for us to just like, if new developers come into the team or we hire new developers, the ramp-up time is super important. And how is your developer satisfaction overall? So we ask all these things, and I just like want to know from you now, if you can take out your phones, scan the QR code, what is your biggest developer joy challenge from these things here? Is it speed to ship quality code? Are you struggling mostly with that? Is it waiting time, that you spend too much time waiting on things? Is it execution independence, that you just like depend too much on other teams to get your job done? Is it access to tools, just like have to use buggy tools or whatever, processes and practices? Maybe there are no practices, good practices, how you deploy or how you just like build a new microservice or processes in place. Effort managing external standards like security and governance, the ramp-up time, or managing your code pipeline infrastructure, the ramp-up time for new developers, or is it generally that your developer satisfaction is just like unsatisfied and you can't really say what it is? Just like do that. So let's see. Let's see here. What does it look like? All right. 36 people have already voted, 39. Okay, we're getting into it. Okay. Developer satisfaction overall is fighting, managing code pipeline and infrastructure. That's interesting. I've run the survey a lot of times, and this is super interesting to see. So, yeah, I would just like to say at most conferences that I've been to, wait time is the most thing people struggle with. But great to see, like here it's like even out between managing code, pipeline infrastructure, developer satisfaction, and wait time. Okay, cool. Good to know. Okay, getting that back. So, thank you very much. Super interesting to see. So you can also see what other people here in the room are struggling with and see that you are not alone, right? You're not alone. Okay, great. So as I said, we're measuring these things, but we don't only ask, right? How satisfied are you with that? Because we have so many teams. We are over 5,000 engineers at Atlassian. So every team is different. So we also ask like, so for example, ramp up time might be not important for some of those teams. So we just like also ask, how important is that for your team, right? How important is that and how satisfied are you with that? And out of that, we're calculating a so-called opportunity score. So you can see just like when you're in the Y corridor, it seems like this area is fine. If it's getting down to that, so it is important and you're not satisfied with it, well, it gets a little bit into the, you should look out of it. If you just like underneath that, you're just like, you really need to do something. You should talk about it as a team. So we are actually giving the survey results to all the teams to say just like, here's what your team is struggling with. To just like, also to encourage people to take part in the survey next time, because we're running them monthly, but also to just like see this team is struggling with that, so what can we do about it? What can this team do about it? The other area that is up there is just like you're satisfied with that, but it's also not important. Anyway, so if you just like want to try that out, I have another QR code for you to scan. I have done a type form where you can just like ask yourself, self-assess you with importance and satisfaction. So try that out, and even more, just like maybe you take that and ask that to your team and try that out. I guarantee you, I don't collect any email addresses or anything. It's just like a simple survey, simple type form that you fill out, and you get the result at the end. Great. So now that we know where we're struggling with, right? You saw that teams were just like going in and trying to fix things, right? So how do they do that? As you saw, just like we giving teams 10% of the time, but how do you use your 10% of the time to fix your things? So some teams organize the developer joy hack, right? They use the 10% to just like take I don't know, every 10 weeks, just like 1 week off, or just like every seven weeks, 1 day off, and just like do a developer joy hack. Other teams use 20% time, so they say we just like arrange it on a Friday or whatever. Some teams do a developer joy week, as I said, less like taking a whole week off to just like work on issues. And other teams included actually in their actual sprint planning and work on developer joy or developer productivity issues there, right? So if you try to fix things, also if you have fixed some things, right, you need also take time to just like spread the learnings. It's great that you solved it for your team, but other teams can just like benefit from that too. So not just like your team can benefit from it, but other teams too. So take, for example, the Punit bot that we talked about, or that I talked about, right? The team wrote a blog post and wrote about all about how it works, why they build it, how it helps their team. And guess what? Now there are 30 teams running the Punit bot in their teams. Not every team is doing that, and we don't want to just like push things on people, but a lot of teams are actually using the Punit bot. Great. All right. 3 minutes left, sorry. Just like to sum this up here, right? First, take your measurements and your survey results if you just like want to measure something. Your measurements will show you some signals where you have to do something. Talk about it during checkups. Also include the survey results. Then, just like, as I said, we have autonomous teams, and give that to your autonomous teams, and then give them also time to fix things, right? That way, they can actually work improving their developer quality, their developer progress, and the value that they create for the customers. And think about that, right? And I always wanted to do a Venn diagram in my talk, and right in the middle this is really where developer joy is actually happening. If I work on high quality code, if I just like can bring things up to speed, right, to my customers. And if my customer says, this is the right thing that we needed, Sven, this is great, and you enjoy what you're doing, and guess what? You're also productive. Because we just like decided for being a developer for a reason. And we just like have, as I said in the beginning, such a great job. We create things for customers that is actually usable. Such a great opportunity. So don't forget to have fun while you're doing your job, right? Thank you very much. Have a great evening, great weekend. Thank you.